Alright, section 2.4 is called curves and circles. Lots of definitions in this section. So we're going to start by talking about the triangle. It says a triangle is a union of segments that connect three non-collinear points. So let's start with three non-collinear points. Let me make it bigger. 1, 2, 3. Non-collinear means not on the same line. We've already talked about what segments are. Segments are 2 points and every point in between them. So, definition of a triangle: 3 non-collinear points and the segments that join them. So, that's important to know. You can also see that there are 3 angles in a triangle. So, here's one, and here's one. And what you have is you have a ray here and here with a common vertex. Then you have a ray here and here with a common vertex. You have this common vertex for this ray and this ray. So it's the union of 3 angles as well. We want to talk about opposite sides real fast. So let's call this A, B, and C. If you are asked about the opposite side of vertex A, okay, then you're basically just take this and go across. It would be segment BC. Okay, you only have 3 segments to choose from, and if you would have chose this one, it would have included vertex A. And so you're not going to get opposite if you're including it. And you know that looks really obvious on this triangle right here. But what happens when you have a triangle that looks maybe more like this? So this one and this one are opposites because it goes across. So just another picture on a slightly different shaped triangle. Alright, next we have these curves that we're going to go over. And it says, you could probably look in your book and see them better. A closed curve is a curve that begins and ends at the same point. Very simply start here. Make an exaggerated point if you want, or just put your pencil down, either way. But you can do whatever you want. Okay, as long as you begin and end on the same point, you have something that's called closed. Simple now, a simple curve is a curve that doesn't intersect itself. This one intersected itself right here, so it's not simple. So, but it doesn't say anything about being closed, right? So, this right here would be a simple curve. It doesn't intersect itself. Now you have simple and closed. Simple and closed. So it doesn't want to intersect itself, but it did have to start and end at the same spot. So simple and closed takes all of that into account. So let's talk about a triangle for a second. Is a triangle a closed curve? Yes. Alright, just because all mine were kind of rounded curves doesn't mean that this right here isn't a simple closed curve. Okay, I never lifted my pencil up or my pen, and I started where I stopped where I started, so it doesn't intersect itself. It's also a curve, so we're going to put triangle in the idea that it's simple because it doesn't intersect itself, and it's closed because it begins and ends at the same spot. Alright, next page, page 56. We have some more definitions here. And the one that we have of, let's see, a circle, it says, is the set of all points that are a given distance from a given point. So there's a couple things that we have to have here. A given distance and a given point. So start with your given point. We're going to say it's this one. That's going to be our center of the circle. Let's say our given distance, I'm not going to give it like an inch or whatever. I'm just going to say, what if it was about that long? Okay. You could say it was an inch. I'm not sure. But anyway, that's you have to have a specified distance. So want to come out, I'm going to say it's about that far. I'm going to come out this way. It's about that far. It's about that far. I am eyeballing this, so you might think it doesn't look good. But if you took the set of all the points that were the same distance away from the center, you're right, that looks terrible. Anyhow, all of these points you would measure from the center, and they should have the same distance. So the definition of a circle is this set of points right here. The set of points that are a given distance from a given point. So we thought we knew what circles were. We knew what shape they looked like, but we have a formal definition now. This is the center of the circle. The distance that we chose, okay, the distance is what we call a radius. It has to go from the center to a point on the circle. We have a definition called a chord of a circle. And it says that it has, first of all, it's a segment. Okay, a segment. The radius is a segment also, because there's the 2 points, right? But it's a segment whose endpoints are on the circle itself. Okay, so pick any 2 points on the circle. This one and this one. If you do a connector line to make a segment, you have made a chord of the circle. And so we have a diameter. I'm sure you guys already know what a diameter is. But a diameter is a special chord, so it is a chord, but it's the one where it has to go through the center. So a chord has its endpoints on the circle, so a diameter has to do that. But as it's connecting from one side to the other, it would have to go through the center. And then it says an arc is our last one that we're learning. Arc is a curve that is a subset of a circle. So we should know arc. We're back to not focusing very good, but the arc, it says, is a subset of a circle. What does a subset mean again? Subset is a portion of the bigger thing. So here's my circle. So I'm going to take this part right here. It got really thick, but this part from this point to this point, call it X and Y. Okay, right here. That is a portion of the circle, and its notation is going to be X, Y, and you put an arc over the top. That's how we know you're talking about arc XY. Okay, next we have 2 more definitions that are interior of a circle and exterior of a circle. They are what they sound like, interior and exterior, but we have a definition that is, more complicated, of course. So the interior of a circle, exterior of a circle. Let's start with the interior. So here it is. Interior means all the points that are inside. But what you would say is that take any point that's inside. Let's take this one, this one, this one, this one. Okay, that's on the interior. And if you measure their distance from the center, okay, so let me just go and say that, how about the radius for this one is 10. Okay, if we knew that the radius of this circle was 10, which means that from the center to any point on the circle it's 10, then if you were on the interior, your distance is less. So this one is like 9.8. This one is 3. This one looks like 7. And this one looks like 7.25. Anyhow, so all you have to do if you're trying to check is a point in the center, or sorry, in the interior of a circle. You just see how far away it is from the center. And if its distance is less than the radius, you know it's in the interior. So you could use the same idea for exterior of a circle. Here, here, and way down here. If I know that these 3 points are in the exterior, then what would happen is if I measure from the center of the circle, it's obviously going to be more than 10 because 10 stops right here. And this looks like maybe 22. And then if I measured this one right here, that one's going to be an 11. If I measure this one up here, you end up with 14. That's how far away it is from the center. So that's what the definition of the interior and exterior of a circle. It says the set of all points whose distance from the center of the circle is either less than the radius for interior or greater than the radius for the exterior. Now we have theorem 2.1, also known as the Jordan curve theorem. So let's take a look at that. It says any simple closed curve divides a plane into 3 disjoint sets: the curve, its interior, and its exterior. So let's talk about a simple closed curve. So let's take a plane. Now let's draw a simple closed curve. So there it is, a simple closed curve. What happened just now is this curve right here separated the plane into 3 disjoint sets. And you could see that it will be the outside, known as the exterior of the curve, the interior of the curve, and the curve itself. You should be able to spot the three sets now that are made because of this curve: the exterior, all the points on the interior, and all the points that make up the curve itself. Disjoint means they don't share. So the curve itself is not part of the exterior, it's not part of the interior, it's all by itself. So that's the Jordan curve theorem. And then we have the very last definition is region. If you want to know what a region is, you have to put this curve and its interior together. So I can look at this one. Here's a curve. All the points on the interior make up a surface, which is actually a real definition we're going to get to. But they fill it in until it looks solid. So a region is going to be the curve plus its interior. And by plus, I really mean the union. The region is a curve plus its interior. So use that information to work on your homework here. We're going to go with 1 through 35 all. And once again, this is section 2.4. Let me know if you have any questions.